Hello and welcome to the PolyTie Getting Started tutorial. In this tutorial I'm going to show you how to use PolyTie's collider brushes to quickly sketch and test a level. For this purpose we're going to create a little platformer game that features a concept from an old but classic movie you might or might not recognize. But enough with the rambling, let's get into it. So first of all we're going to start with your typical empty Unity project. The layout is reset to factory setting. So I'm going to start to change the layout a little bit more to my liking. I'm going to shift the window around a bit. Now to the more interesting stuff. You can see that PolyTie is already installed by looking at this folder here. This means we already can access the PolyTie windows. If we click on Window, we already see the PolyTie submenu. This contains both PolyTie windows, the 2D brush window and the display settings window. We're gonna start with the 2D brush window. This window contains all the collider brushes that PolyTie supports. You can see polygon collider, circle collider, rectangle collider, edge collider, and the path collider. I'm gonna bring this down to the bottom right of the screen. Let's look at the second PolyTie screen, the display setting. This window lets you specify the appearance of the colliders and the drawing gizmos. It also provides an additional 2D grid. I'm going to position this window at the bottom left. Now let's have a closer look at all the options. First, you can change the color palette that PolyTie uses to draw colliders. In that case, I keep the settings on night. Vertex size specifies the size of the gizmos that are drawn for each vertex of the collider shapes, like polygons or edges. Show vertex info will draw the position information for each vertex on the screen. This can be useful for debugging. Grid size sets the size of the 2D grid, which can be used to snap vertices or edges too. When drawing out the first concept, I always like to specify a grid, because it helps me to keep concept nice and tidy. So I'm gonna set this value here to 1. I also want to turn snap to grid on, and I also want to show the grid. But the grid is not showing up, so why is that? This is because we haven't added the brush to the debug camera yet. We need the debug camera to draw things like grid or the filling of collider shapes. So for instance, if we draw some shape now like the circle, you will notice that it just shows the wireframe without any fill color. Also I have to click directly on the wireframe to select it, which can be quite tedious. I want to click inside the shape to select it. And if I hit play, the collider also doesn't show up in game, although I could turn on gizmos to show the wireframe. So we're gonna add the debug camera now. To do this we go to Edit, where we'll find the submenu PolyTie, and we select Add Debug Camera. Hooray, it draws the grid and the circle has a fill color now. Let's see if I can select it by clicking inside. Yes, I can. What it basically did was adding the physics debug renderer script to the main camera in the scene. This is just a simple script that draws collider shapes onto the scene and game view and handles some selection events. So let's start off with our little level. First thing we need is a floor. To create a floor, we're gonna use a rectangle brush. As an object type, we're gonna select a static object. Static objects are not affected by forces or gravity, and this is what we usually want from a floor in a platformer game. In Unity, static objects are actually kinematic objects. They just have zero velocity. We're gonna start drawing out the floor by left clicking and dragging the mouse. That was pretty simple. If we hit play, we will see the collision shape. If we are not happy with the size of the rectangle, we can change that. If we hover over an edge, the edge turns red. If we click and drag now, we can change the size of the rectangle like this. We can also hover over a corner. It turns red again, and we can click and drag the corner to change the shape. The next step would be creating a wall, because we want the player to move to the right and not fall off to the left. A wall works exactly like a floor. So we're gonna create another static rectangle to the left. I'm gonna change the size of the rectangle a bit. Maybe the other one as well, and there we go. This is a very basic start for a platform, and that's quite boring. Usually we would expect some challenges, like gaps that we have to jump over. So I'm going to add some more static rectangles to create gaps the player must jump over. I want to add another gap, so instead of using the brush tool again, I'm gonna duplicate the rectangle I have and move it. What we see is that if I move it, it doesn't snap to the grid. This is because Unity has a separate snap function for transforms. So I'm undoing this movement. I'm gonna set up the snap function to match the 2D grid size. In our case, the 2D grid size is 1, so that is already set up. If we go back to our rectangle and move while holding down the control key, we see now that it snaps to the grid. So I'm gonna repeat that to create another gap. Changing the size of the rectangle a bit. So now we have some sort of a platformer setup. So next we want to test that out to make sure the player is actually able to jump over those gaps. For that purpose, I'm gonna bring in a 2D character controller, which I shamelessly robbed from a platformer game I've been working on. I'm going to copy the prefabs and scripts into my Unity test project. Wait for the scripts to compile, and there we go. I quickly shrink the project display. Next I'm gonna bring in the player character prefab. It comes already with another main camera, so we're gonna delete the default one. The player character camera has already added the PolyTie debug camera view. I quickly adjust the position a bit. Before I can test it, I have to do a short setup for my character controller to work. I have to assign a ground layer to all the static objects that the character can stand on. This is due to how the movement script of the character works. I'm gonna go to layers, add layer, and I'm gonna add a ground layer. Next I'm selecting the static rectangles and set the layer to ground. To keep things structured and tidy, I'm gonna add an empty game object and call it ground objects and zero it out. And then I'm making all the static rectangles a child of ground objects. Let's see if it worked. I can walk around and can jump, and there I already fall down the first gap. As you can see, we keep falling, and that's probably not what we want. Usually we want our player to be resetted to some previously saved checkpoint. To realize that, I'm gonna make use of the killing zone object PolyTie comes with. I'm gonna use the rectangle brush again to create the killing zone object. You might notice it has a different color than the static object. You can customize the color palette as well, but we're gonna talk about that in a different video. So let's talk about the properties of a killing zone. The first parameter is a respawn point. If you leave that empty, the killing zone will simply destroy every object it collides with. If you specify a respawn point, the object is teleported to the position of the respawn point. So this is what I actually want to happen. You find the respawn points prefab under Assets PolyTie Prefabs. I'm gonna drag one to the start. I might as well give it a meaningful name like player respawn 1. Then I go back to the killing zone, click here and select my freshly created respawn point. Next I'm gonna talk about the affected layer property. For this property you can specify that only objects that are part of a certain layer collide with the killing zone. At the moment everything that collides with the killing zone is teleported to the respawn point. Usually what you want to happen is that only the player is resetted to the respawn point. So what I'm doing is I'm gonna create another layer for characters. Go to add layer and create the characters layer. and then I'm gonna assign this layer to our character. In the pop-up I select that I only want to set it for this object. At the affected layer property I first select nothing to deselect all layers, and then I'm selecting the character layer. Let's see if it worked. We walk along, oh no, we fall, and we are resetted. Great! Next I want to change some parameters of the character. The movement was a bit slow, so I'm cranking up the speed a little bit. The jump is a bit too high, so I'll bring down that value. Let's test again if it's still possible to jump over the gaps. Nearly. Maybe I should move the camera down a bit. Let's give it another try. Well, that seemed to work. So let's look at our next section where I'm going to introduce the moving objects of PolyTie. I'm going to start off with creating a concept for a cave or a temple, and for that I'm going to create a ceiling. For this I want to use the polygon brush tools. I'm going to polygon objects and select static. This will start the polygon drawing process. With a left click I can add vertices to the polygon. You might notice the vertices automatically snap to the grid when creating them. Once I'm happy with the shape, I can right click to close it off. If I want to add vertices later on, I can do that by simply selecting the polygons and double clicking on an edge. I can also manipulate vertices. If I hover over the vertex it turns red, and now I can click and drag to change its position. And if I want to delete a vertex, I just simply right click on it and select delete vertex. Next I want to create a gate that opens once the player approaches it. To realize that, I'm going to make use of moving objects. So I'm going to go to rectangle brushes and click on the moving button. Click and drag to create a moving rectangle. So let's have a look at the properties of a moving object. As you can see, it has already a few scripts attached to it. In the platform mode script, we find the property speed. This is quite obvious as it determines how fast the object is going to move along the specified path. I want to open the gate slowly as it's a mysterious gate, so I'm going to change this to 1. Let's look at the other properties. The moving snappiness determines how fast the object reacts to velocity changes. The target threshold determines the fuzziness that is used to determine if the moving object has reached a waypoint. You would have to increase that value if you use higher speeds. For now we're gonna leave those two properties at their default values. Next I'm gonna explain the patrolling controller. The first property is the patrolling path. Here you can specify a vector path to the object which the moving object should patrol along. I'm going to create the path now by clicking the path button. Similar to the polygon creation, a left click adds a vertex to the path and a right click finishes the path. Manipulating path vertices works exactly like with polygon vertices. Once we hover over a vertex, it turns red and we can click and drag it to a different position. I rename the moving object gate and I'll give the path the creative name gate path. I also want to create an empty parent object. I'm gonna call this one moving objects and make the gate and the gate path childs of it. I'm quickly gonna add the static polygon I created before the ground objects and change its layer to ground, just in case we want the player to walk on top of it at some stage. So now let's look back at the moving object. I'm going to select the gate path as the patrolling path. So let's look at the looping parameter. If this box is checked, the moving object is going to patrol back and forth along the path. If you check the move on start box, the moving object will start patrolling along the path as soon as the game starts. So this is not really what we want. What we want is the gate to open once the player reaches this part of the level. To accomplish this, I'm going to use PolyTie's trigger object. This object I want to use an edge brush. So I go to the edge objects and click trigger. Again, left click adds vertices to the edge. You probably noticed that it already draws a line. This is due to how Unity handles edges, as they always must have one vertex. So the first one is added to the origin by default. As soon as I place a second point, the helper point at the origin gets removed, and we can continue as we could with any other path object. Our right click again finishes the edge, and I'm gonna move it closer to the gate a bit. Now let's look at the trigger controller component. First, you can see the routing property. The routing property specifies where the trigger events like on enter, on stay, or on exit should be sent. They can be sent to the game object the trigger controller is on, or a target object you can specify in the second property, or even both. So with our second property, we can specify a game object that our trigger should send messages to. What we want to do here is we want to route the onEnter event to the moving platform to kick off the movement. So I'm going to select the gate object as the target. Now as soon as the player collides with the trigger object, this gate should move up. Let's have a closer look at the checkboxes of the trigger controller. With those we can specify which events should be routed. There is the onEnter event, which is fired once the object enters the area. The onStay event is fired every frame an object is within the trigger area. Finally, the onExit event is fired once an object leaves the trigger area. The last checkbox specifies whether the trigger object should be destroyed after it fired, which we want in this case because the gate will open only once. So let's give it a test. Jump over our gaps. And there we go. We pass through the trigger and the gate opens. Yay! So now to the next part of the tutorial. To make things a bit more interesting, we are going to add some hazards to it, like falling rocks or fireballs or whatever. First I'm gonna extend the floor a little bit. Then I'm gonna add another rectangle object as the ceiling. And I'm gonna move it to the ground objects and set the layers to ground. So let's create a falling hazard. I'm gonna use dynamic circle collider objects for this. So I go to circle objects and click dynamic button. To place the circle, I just have to click and drag somewhere in the scene view. To make it an actual hazard, we're gonna add a killing zone collider to it. So we create a killing zone from the circle brushes. Then I'm gonna make this killing zone a child of the dynamic circle. The killing zone will now follow the dynamic circle. A dynamic object is affected by forces and therefore adheres to gravity, which means it should fall down. To match the position, I'm gonna zero out the transform of the killing zone object. I'm also adjusting the radius of the killing zone a bit. Then I'm gonna give it a meaningful name like Hazard 1. Gonna adjust the position a bit. Next I'm gonna set up the killing zone so it only affects characters. And I'm gonna set the respawn point to player respawn. Next I'm gonna create another gap. I duplicate the static rectangle and move it aside a bit. Then adjust the size, and there we go. And we want to extend our killing zone as well. I'll bring the character over to test it. As we can see, the hazard is falling down, but it only falls once. What we actually want is it falling down in certain intervals. So to realize that, I'm gonna use the killing zone object again and set it up specifically for those hazards. I select a rectangle killing zone and create a killing zone right below the falling hazard. I'm gonna rename this Hazard 1 killing zone. What I want is that the dynamic circle spawns right at its start position again. So I'm dragging a respawn point in and position it right at the circle position. Gonna rename this respawn point Hazard 1 Respawn. Next, I'm assigning Hazard 1 Respawn to the Hazard 1 Killing Zone target. Next step is to create a layer for hazards. So I'm going to add a layer and create a hazard layer. Then I'm gonna set the layer of Hazard 1 objects to hazards. And again, I'm gonna select this object only in the pop-up. Finally, I change the affected layer to the hazard layer of the Hazard 1 Killing Zone. If we test this now, the falling circle should respawn at the top again and fall down in intervals. This creates a constant hazard for the player. So before moving to the next section, I'm gonna clean this up a little bit. I create an empty object called hazards and zero it out. Add hazards 1 to the hazards group. Then I might want to create a respawn points object. And another one called killing zones. Then I'm gonna add respawn points and killing zones to their parent objects. Now I want to create some more of the hazards to provide some more challenge to the player. I'm gonna duplicate the roof again, adjust the size. I'm gonna duplicate those two, bring them over a bit, and again. Then I'm gonna duplicate the hazards, bring them over, and change the starting position. This should give some diversity to this challenge. Next, I'm gonna rename and number them properly. And I'm gonna extend the killing zone again. Next, I duplicate the hazard killing zones. Then change the name and number them accordingly. I also need respawn points for each new hazard, so I'm gonna duplicate the first one, position it at the second hazard, and rename it hazard 2 respawn. And do this again for the third respawn point. Now I just need to assign the right respawn points to the right hazard killing zones. Zone 2 to respawn 2, and Zone 3 to respawn 3. So now we should have a nice challenge for our player, so let's test it out. And there we go, we got knocked out by a falling rock. So this works, and we're gonna look at the next section. Every platform has some sort of moving platform the player has to jump onto. First, I'm gonna extend the floor a little again. And create a big gap. I also want to extend the roof. I'm gonna make use of the moving objects again. I go to rectangle brushes and create a moving object. I'm adjusting the gap a bit. Next, I create a path for the platform. So let's give those objects some meaningful names. I call the moving object platform, and I'm gonna rename the path platform path, and I finally moved them to the moving objects group. Now I'm ready to set up the moving objects controller. I'm gonna leave the speed at its default value for now. I assign the platform path as the controlling path. I want the object to loop, and I want it to move from the start as well. I might adjust the length a little bit. And don't forget to extend the player killing zone. We also need to set the layer of the platform to ground. Also, to allow the character controller to move with the platform, I have to set up tag property. The character controller makes use of a specific tag setup to figure out if it's standing on a moving platform. So we have to add a tag called moving platform. And assign this to the platform we just created. Now we are ready to test. Seems to work fine. Next, we're gonna create the ramp that leads the player to the final collectible. First, I'm gonna extend the floor a little again. So we're gonna use the polygon brush tool to create a static object. Again, with left click, I'm adding vertices to the polygon. I want to create two slopes and a plateau to place the collectible on. And I finish off with a right click. Finally, I'm going to adjust some of the vertices. I'm gonna bring over the roof a bit as well. Then I assign the ground layer to the static polygon and add it to the ground objects. Next, I want to create the collectible. This I'll make use of PolyTie's trigger object as well. I want to use a circle collider for that. I click on trigger and draw out a small circle in the scene view. I'm gonna adjust the radius a bit. Next, I want the collectible only listen to on enter, so I uncheck all other boxes. And I want it to be destroyed on trigger. Finally, I'm gonna rename it to collectible. To spice things up, I want to create a trap for the player. To create this trap, I'm gonna make use of the hazards I created before. So I simply duplicate one of the hazards, bring it over, change the radius, of course I have to adjust the killing zone as well. And I'm gonna call this hazard boulder. I'm gonna put our boulder up here, but right now it will just roll down and the player probably won't even be here to see it. So to change that, I'm gonna make use of the moving objects again to create a proper trap. So I'm gonna create a moving rectangle object. I'm gonna place it somewhere here. And again, I'm gonna create a path for it. I'm gonna rename the platform Trap. And the path I'm gonna call Trap Path. Then I assign them to the Moving Objects group. Finally, I assign the Trap Path to the Trap Moving Object. I'm gonna leave all the Moving Object properties at their default values. So what I want now is that the collectible triggers this moving object so that the boulder starts rolling down as soon as the player collects this collectible. To do this, I'm gonna simply route the onEnter event to the trap object. So I select the trapped object as the target and set routing to only target. Now let's test it. We collect our item and there it comes. Beautiful. So that's it. We created a level concept. I think we deserve a playthrough now from the beginning. We have our gaps to jump over. There is the mysterious gate to the even more mysterious temple. Then we face this vicious falling rocks and fireballs. But we made it still, and we can continue on. We jump on that platform. We walk up the slope. There our reward. And here comes the boulder. Am I fast enough? No. So that's it. We could now export these collider shapes and an artist can draw beautiful assets around it. If you want to know more about the asset workflow, you're very welcome to watch the PolyTie workflow introduction video. So thank you for watching PolyTie Getting Started tutorial, and I hope you enjoyed it. If you're interested in more details about the project, look at the Unity Asset Store or find us under polytie.com. Cheers and bye bye.